everyone. Welcome back to Mavens of Manufacturing. And I know this is completely out of character for me because it's Wednesday and not a Friday, but when the topic is so much fun and important to discuss, I can't help myself and I got to change up the rules a little bit. And that's okay because I own Maven. So whatever. If you're here today and you're in the comments section, please drop that you're here and where you're tuning in from. I love to connect our guest members with our audience members. But this episode is 133, which is pretty crazy. And it's sponsored by the ISA, or the International Society of Automation, who we have a special message from after this episode. So be sure to stick around for that because it involves a sale that they have going on this month. So don't miss that. If you do, we have the recording. It's on YouTube. You can subscribe there and you can get the link that way as well too. I have two guests today, which is super exciting because normally I have one. Again, we're breaking all kinds of rules today, and that's totally fine. So please welcome Aaron Sykes and Stephanie Rispa. Aaron is the STEAM Outreach Coordinator for the National Center for Autonomous Technologies, or as they like to call it, NCAT, because we can't get enough of our acronyms here in this sector. And then Stephanie was a former English teacher. Yay, English majors. I love that. From Grafton Public School, and she is now the Equity and Inclusion Communications Director for NCAT. Hello, you two. Welcome. Thank you so much for taking the time today and joining me for Mavens of Manufacturing. How are you?
We are doing awesome.
Very good.
Awesome. So I always like to start out with my guests introducing themselves and providing some background information. So Aaron, do you want to kick it off and let us know who you are and how you got involved, not just in engineering and manufacturing, but also as NCAT?
Yeah, absolutely. So at the end of the day, I'm just a big aviation nerd. Is really what it boils down to. So I grew up in eastern Wisconsin. Anybody from that part of the world knows that Oshkosh Experimental Aircraft Association has one of the largest air shows in the world. So I grew up working there, and it's been a love affair with aviation ever since. Had a chance to go to North Dakota to do aviation degrees up there. Worked for Department of Homeland Security, Science and Technology out in Colorado for a few years, and then moved back to Minneapolis. Started a drone group. We ended up growing to 1,000 members right before COVID. Did some collaborative work with the FAA. Did drone brewery racing during the cold winters here in Minnesota, which was super cool. And then had a chance to do some commercial UAS work as well. But through all that kind of work, got introduced to NCAT.
Just to stop you real quick. So the drone brewing racing, I'm going to have to connect my friend Chris Lukey to this because he does the manufacturing happy hour, and that sounds like right up his alley. So if you're still doing that, or if you want to reintroduce it, he would be the person to help you out with that. But then I'm sorry that I interrupted you. I just thought that was
I'd
really
love to chat with Chris. The really cool part about drones and aviation is that no matter where you go, you can find some super, super passionate people about it. And, you know, I'm a little bit biased here, but truly autonomous systems are a really good gateway drug to aviation, to drones, to mechatronics, and then by extension manufacturing, right? So through all that, had a good chance to meet John Beck, who's the executive director of NCAT, brought me on board here 3 years ago now, and loving everything ever since. The only real tie that I have to manufacturing formally, though, is my grandfather started a tool company in Novi, Michigan after the Second World War, and it's currently run by my uncle, Floyd. So Echo Tool in Novi, Michigan. Hopefully somebody's listening.
Nice. Well, I always am happy to welcome a former Northwesterner, like a Wisconsinner, because I'm from Wisconsin too. And it's great to have someone on with a similar accent to mine, because some people like to point out that I have a really long O sound in some of my, and it's only exaggerated now because I have a cold, so it sounds great, like I'm from Fargo or something. But that's
how do you say bag and milk?
I say bag. My sister says bag, and then she says milk, which I don't. Yep. Yeah, she says milk, and I'm like, it's ILK, and she's like, no, it's milk. I'm like, okay, that's fine. We'll
as long as you drink from a bubbler, we're set.
I can't do that.
Oh,
I do say, so do you say pop or soda?
I say pop.
Okay. I say soda, but we're from the East Coast.
Okay.
Initially we used to call everything Coke, but
Oh, yeah,
then
yeah.
we learned that wasn't right. So then I switched to soda, and then now all of my Wisconsin friends are like, it's pop. And I'm like, okay,
Mm.
I'll try to switch it to pop. But Stephanie, it's your turn. How are you doing? And then, how do you fit into all of this? Where did you start off? And
I'm doing well, and I grew up in North Dakota, so I have the epitome of the accent. Um, my background is in education. I taught for 10 years English, specifically literature, so nothing to do with manufacturing.
Not at all.
I just landed in a world that I have been really working hard to try to figure out and understand. But my background is really working with diverse groups and underrepresented students and families, specifically a lot of families who are living well below the poverty line. And so my new role as NCAT's Equity and Inclusion Communications Director is dedicated to reaching out to these groups and helping ATE and NCAT break down barriers where we can that have kept people from believing that they can be a part of these lucrative and rewarding careers in manufacturing and in drones and aviation.
That is super cool. So how did you get introduced to NCAT?
Honestly, I was just looking for a career change, and I started applying to two-year colleges because I knew I wasn't, I didn't have a master's degree or anything like that. So I didn't figure I would be, working at a college, but I knew I didn't really want to teach. And I just applied here because I love people, and the diversity really part of it really kind of pulled me in for this particular role. And I didn't even know what NCAT was until until I landed here. So
I didn't know what it was either until I met both of you. But I want to introduce you to Andrew Crow, because he's doing a lot for diversity and equity and inclusion in the manufacturing space, and he has a really cool story. And I'm sure he would get a kick out of hearing about NCAT and about what you guys are doing. So let's dive deeper into what NCAT actually is and some of the things that you're working on. So right now, you work with autonomous technologies. You mentioned drones. So can you kind of paint a picture of what the current state of autonomous technology is, especially here in the United States? Like, do you have some stats for us that you can share?
We have stats. But before we get there, what might be more helpful, especially for your audience, is to just back up for a quick second, who NCAT is, and what the NSF ATE program is. So simply put, it has never been more exciting to get a 2-year degree than it is right now.
I'm glad that you say that. That's awesome.
It truly, I mean, there's some stuff that we'll get into a little bit later in the podcast here, but if you want to talk a little bit more on Steph's role and vein, is social and economic mobility. There is no greater return on investment than a 2-year certificate, hands down, without question. One of the things that's really interesting about it, though, is that the 2-year certificate has really evolved over the last 2 decades, right? If you're going to go to school for HVAC, you have to know computer programming. If you're going to go to school for automotive repair, you have to program lasers, right? When you start talking mechatronics and all the stuff that you folks do in manufacturing, it's the exact same way, right? Yeah. And so there's really kind of a emerging challenge that's really started to first notice in the 1990s, which is why they created a program called National Science Foundation Advanced Technological Education. And that is a fantastic suite of resources for high schools, mainly 2-year schools, but also employers, to really get connected with that network, because the amount of support that it offers is truly unparalleled. They also sign stuff in my paycheck, so but truly.
So you're like, that's why I had to drop that in there. So
and there's 29 centers throughout the entire United States. So it's not just NCAT. Focused on anything from mechatronics. Some folks do micro nano, so talking about the CHIPS Act and stuff like that out of California. There's 29 centers that cover pretty much every industry area around, especially manufacturing, advanced manufacturing, additive manufacturing, stuff like that. And so what's really nice about that is whether you're an employer or a two-year school educator, you don't have to go it alone, because especially figuring out all the stuff that's out there can be incredibly overwhelming. And that really boils back to who we are as NCAT and the role that we fill. Everybody loves drones. Everybody loves to talk about drones. Where it gets a little bit cloudier is where the rubber really meets the road. And that is what we have been tasked by the NSF ATE program to specifically do. So NCAT, again, in the world of acronyms, is the National Center for Autonomous Technologies. And we focus on two things. We focus on the skilled technical workforce development for industries related to air, land, and sea autonomous technology. So this covers the physical manufacturing, this covers the programming, this covers the operations. And really what we do as a resource is we work with two-year schools to give them content, curriculum, and connections to allow them to integrate this really exciting part of the world into their classroom. And it takes form in a few different ways, but that at a basic role is really where we're at.
Okay. So then in terms of like NCAT as an organization, and I mean, you're both part of the Midwest. Is it just focusing on schools that are in the Midwest, or is it a national type program?
So we have NCAT partners in air, land, and sea. We're a diverse group of men and women, including myself. Jill Zandy, who's the director of MATE, she's out in California. We have Pam Oakes in automotive. Mel Cassette, she's the director of MAT EDU, and we're located throughout the entire United States. We have different backgrounds, different experiences, different valuable insight that we bring. So everyone brings something different to the table because of their location, because of their culture, and et cetera.
So then when we're talking about drones, though, like what is the sizes that we're talking about here? Because drones can be as small as, a hamburger. That's the first thing that popped in my mind. So yes, can you tell I'm hungry? A hamburger, but they can also be as large as almost an airplane. So what are you working with all kinds of sizes?
Yeah, so it's a really good question, especially kind of demystifying what this space really is. Like, if we're all just honest with ourselves, they're big remote control cars and big remote control airplanes, right? We're not talking about any brand new technology. I mean, there is brand new technology involved, but a lot of the underlying framework really comes from legacy industries. As Steph was saying, we are funded through NSF, so our operational area is the entire United States. In addition to the great folks that she mentioned, we also have a chance to work with folks like the FAA, and we are the repository for their drone collegiate training initiative. And so what we really serve, one of our primary roles is serving as connector, both within academics and then academics to industry.
Okay.
But back to your super interesting question of the current state of autonomous technology and how big are these things, right? The drones, and I say drones inclusively, so all autonomous tech, is really at a very interesting inflection point right now, where no matter the domain that you look at, they're getting really serious about the transition from research to commercialization. The X's and O's, the engineers have solved all the problems, and now it's down to marketing and manufacturing to bring home the bacon, truthfully. So across in the aviation world, aircraft can really be broken into the extremes, right? On the large UAS side, you have something like Northrop Grumman Global Hawk that has the wingspan of the 737 that you'll take from Chicago O'Hare down to Florida for a holiday. They're massive aircraft that can stay aloft for up to 24 hours. And graduates of Northland Community Technical College are the only students in the nation right now that are able to learn a large UAS maintenance degree to go and work on those aircraft. But they're not alone, right? There's a ton of really interesting startups that were ideas 8-10 years ago now, that are all really staring down the line of getting their airworthiness certificates and starting commercial UAS, commercial operations. Companies like Beta, Joby, and Archer. They are electric aircraft, so e-aircraft, vertical takeoff and landing aircraft, which we call in the industry eVTOLs. And they're meant to carry roughly 4 to 8 people, distances up to 100 miles. Completely pilot optional, taking all the framework from the small UAS and really connecting it with infrastructure from electric vehicles to make flying cars. Flying taxis are very real. Beta just opened their first manufacturing facility at the beginning of this month up in Vermont. Joby, they announced one this last month for Dayton, Ohio. And then Archer is actually building one down in Covington, Georgia. And they're partnering with Stellantis, the car manufacturer, actually. And so what you're seeing is a ton of really interesting crossover and a really interesting point where emerging technology is where emerging and technology startups are figuring out how they start to manufacture en masse, right? And then you get into the small UAS side, which I comfortably call things that don't carry people. And their FAA has really made strides the last few years to integrate, complex operations, operating in controlled airspace. The big one right now is beyond visual line of sight flying. So you're actually able to fly small drones where you can't see them anymore. And as we're incorporating this into the national airspace system, bringing it back to manufacturing, one of the really big concerns is because a lot of the small UAS manufacturing is done overseas. How do we make sure that that's secure, especially in a sensitive environment? And so they're actually integrating, it's called Blue UAS, that for certain customers, they require everything to be made in the United States. Wow. They're framing it as a national security issue, simply because we cannot outsource manufacturing in the way that we have, especially for this emerging technology.
Well, right. And you don't want somebody from a different country kind of controlling. I don't know if I get like caught up in the whole like sci-fi movie type plot where it's like, okay, if you go into something that's completely automated, then someone's going to take it over and, take you on the thrill ride of your life. So why I'm fascinated by autonomous technologies, I don't know if I would be the first one to volunteer to sit in one and have it take me somewhere, if you know what I mean. Like, I think I'd be hesitant to do that.
It's a really interesting framework, right? Because if you look at this, and it's something we can definitely chat about more, is autonomous technology, very much like advanced manufacturing, is where the rubber hits the road, where digital becomes physical. And there's a ton of really, really interesting, you can even go as far as to call them ethical challenges, right? When the thing making the decision is a computer, is an AI model, right? And it's all about the training, it's all about, the parameters and using a neural network and all this other stuff. But there's some really interesting, you're very right. And it's something that is top of mind, both from a external cybersecurity hardening of especially these larger aircraft, but then also from an internally making sure if they are going to let them fly by themselves, making sure that they know what to do so they don't have any questions and it does what we want them to do. And it's really interesting too, because that's on the aviation side of the house. Then you get into ground based robotics, whether it's, the autonomous cars, Tesla's coming out and, a lot of these have some really interesting, category 3 and 4 autonomous technology features. But then even stuff like agriculture, Panasonic is going in and they're developing a AI driven autonomous wheelchair, which when you start talking about equity and mobility, there's some really, really interesting social challenges that we now have a really unique opportunity to overcome that was completely beyond the realm of possibility 10 years ago. And really all we're using is jacked up remote control cars and a computer. So, it's pretty interesting. And
So you said something that's really interesting to me. Initially we're talking, and I just want to get the jargon straight, because in manufacturing and engineering and anything technical, there's a ton of terminology that can be used the same, but it actually means something different to different companies. So you said autonomous technologies, you said drones, AI, and robotics. So, and if this is a dumb question, I'm sorry, but can robotics be considered a type of drone? Or vice versa?
Maybe. So if you call it mobile robotics, all autonomous vehicles are really nothing more than mobile robotics. The VEX and the FIRST programs that you have, that all of your audience tries to yank them in the manufacturing direction.
Yeah.
We're the other side of the proverbial rope, trying to pull them in the aviation autonomous vehicle direction, really. But what's really interesting is that at the end of the day, they all end up being very related. Drone is a very kind of, that's a very informal term. If you want to get super technical, there's autonomous vehicles, which fly completely by themselves, and then remotely operated vehicles, which actually have a person putting active control on the aircraft or ground vehicle or sea vehicle, right? So the racing drones that we flew in the brewery has usually some 18, 19-year-old gamer that's a rock star flying that thing, right? But when we fly we were flying as part of a National Science Foundation experiential learning project with Colorado School of Mines. We had 2-year students that put a $400,000 drone in the air that flew completely autonomously, right? Once it took off, they hit the autopilot button. They didn't have control of it until it came back. And so that's really the big difference. But the underlying infrastructure, especially from a manufacturing standpoint, is really the same. It's really boils down to, is there somebody at the sticks or not?
Gotcha. So then, go ahead.
No, go ahead.
I was just going to ask you then, is NCAT more focused than on the education side of things? Because you did mention before that it's like created to create content, curriculum, and connections. So then, is this something where you're getting involved at the high school level, or is it at that community college level?
We get involved across the board through our NSF grant funding source. It has to be older than 7th grade. But other than that, we have a lot of freedom. And especially in listening to a few of your podcasts and preparing for this, it's a really common tone. If we start talking about emerging technology or manufacturing or drones or any of this stuff when they're in 11th grade, we're years too late. And unless we can clearly tie, educational pathways to job outcomes, we're not having the right conversation. And so really the role that NCAT seeks to fit into is really this kind of holistic program. And a good example of kind of things that are happening out there, right? And we can get into how NCAT's actually approaching this a little bit more, but, relaying it back to manufacturing, right? So the manufacturing, the autonomous technology industry right now is really transitioning from this research phase to commercialization. As it gets into commercialization, manufacturing becomes incredibly important. And a lot of the stuff that aircraft or UAS use are a lot of this advanced manufacturing concepts. So composite manufacturing, one of the large advanced air mobility, those large people, drone taxis, if you will. Joby out in California actually created their own apprenticeship program for composite manufacturers, for composite techs, because they could not find enough local techs to do the job. You get into additive manufacturing, another NSF ATE funded center down in Wichita. They're actually doing really cool research in, and again, forgive me because I'm not in the manufacturing world, but what I'm calling edge manufacturing. And so aircraft will have, specific parts that they have to have in order to be legal to fly. They're actually doing research down in Kansas right now about 3D printing aircraft parts that break during flight, so that when the aircraft lands at some random outstation, they can switch the part out and put it back right into service without having to send it to a major maintenance hub.
I just was like wondering, why would it break during flight? Like, I would hope it wouldn't do that, but I get your point.
Yes. And I don't want to be, too alarmist on it. There are things that
but that's still really cool, because I was at an additive manufacturing conference not too long ago, and it's interesting to see the types of advancements specifically within that area that they're doing for aviation and defense and aerospace. And it's just, I remember the little desktop printers when they first came out, and everybody's like, yeah, this isn't going to last. It's a phase. And then here we are today. And now they're getting into airplanes and cars and printing out different metals. So it's super, super, super cool. So you kind of went over the issues in the industry that NCAT was designed to solve. Is there anything else that it's really helping? Like, so we have this skills gap going on in manufacturing. And one of the things that a lot of companies are doing is trying to focus on advanced technologies like autonomous technologies and AI and what their generation is all about. So are there certain things that NCAT is doing to help either manufacturers or schools really recruit that next generation? Like, how are you promoting this to the younger generations? How are you even promoting it to parents to kind of get this?
Yeah, we do some really interesting stuff for that, and we can chat about it in a moment. I think what I really like to do is kind of talk a little bit more about the issues in the industry that we're really designed here to solve, right? Because what we're talking about is not small problems. If you look at getting back to what we talked about in the first part of this conversation, is 2-year certificates as a mechanism for social and economic mobility, leading towards justice across different demographics, is something that is hard to overstate, right? If you want to change your life, if you want to change your family's life in 18 months, a 2-year certificate that can easily put you into some of these super engaging, super interesting, super new industries is something that there are people that are in the industry side of it begging for you to fill those roles, right? So at an initial problem, if you step back from the social context that we're talking about, at the end of the day, we don't have enough people. In aviation itself, they figure right around, in the aviation maintenance workforce alone, there's 12 to 18,000 positions that they cannot fill. Boeing, obviously a massive aircraft manufacturer, they have employee shortfalls of 10 to 20% regularly. And then it really boils down to where, if the people that we've been going after so far aren't filling the roles, we have to expand. And that's really where Steph's role, as with communications and DE&I, really, really starts to kind of come into her own, right?
Right, because we found that just over a quarter of manufacturing workforce are women. And when you start to look at the licensed pilots, there's only 10% of them that are women. So 2.6 in aviation maintenance professionals are women, and then 47% of USA workforce in general is women. So we've got a huge gap there that we could be filling with women alone, let alone when you start looking at some of the underrepresented groups, such, like BIPOC, et cetera. So, we can really be focusing on diversity and knowing that when we do that, we're not only filling those roles, but we're bringing new ideas, new perspectives to those roles.
Gotcha. So how are you getting in front of those groups then? Because that's like, I think you said that was one of your challenges before. Like, you're really struggling to like kind of get the message out there. So what are some of your strategies behind, connecting with manufacturers, connecting with schools, connecting with parents, and connecting with that younger generation?
We have really kind of 3 core groups that we try to hunt down, to be honest. So, really kind of on that spectrum of, the high schools, the entire idea is to really focus on educational pathways and provide specific inspiration, right? On the 2-year side of the house, that's where we're really going down and creating collaborative relationships, connecting them with NSF ATE resources, as well as, any industry that we may know of that's in the area. And then finally, we definitely want to collaborate with industry itself. They're for a few different reasons, but, stepping back a little bit to what Steph was talking about, these gaps in education and these gaps in employment, it kind of comes back to these interesting concepts of, especially in the advanced air mobility world, for example.
Mm-hmm.
Most, and this is just in folks that we've chatted with in the industry, you have the engineers, which design the aircraft, and then the test pilots are overwhelmingly, former military pilots. And so what ends up happening is a very small segment of the overall population is designing an aircraft that's going to be used by society at large. And so you start asking, there's this really interesting disconnect of, are there manufacturing inconsistencies, inefficiencies, design elements of the aircraft themselves, or use cases that are overlooked or not researched simply because the group involved comes from a pretty similar background, right? And then if you look at the larger implication of that, if you start to create these aircraft, start to manufacture these aircraft en masse, right? The last thing you want to do is end up with Edsel cars, amazingly designed cars, but amazing manufactured cars, but really they didn't meet the need of what society wanted of a car at that time, and that's why it went out of business, right? So the lasting idea of benefit of increasing equity inclusion, specifically in the manufacturing around large autonomous systems, is what happens when other people are at the table and start to look at that through their experiential lens. And that's where we really see the value of NCAT coming in, because we have that breadth. We have the funding support through National Science Foundation, ATE, so we can focus on a lot of these things that a bread and butter, I got the engineering done, now I got to make a bunch of these things, industry folks may not have the time to really dedicate to. So on the high school side, we really focus on, what is autonomous technology and what is manufacturing. To be honest, I'm still kind of light on the what is manufacturing side of the house. There's fantastic partners we work with. Flight Test, for example, they're out of Ohio, and you can build remote control airplanes with foam board and cardboard. Is that manufacturing? Kind of.
You're building something.
Yeah, the Experimental Aircraft Association has this great program called Aero Educate, and it'll tell you everything you need to know about flight physics. It's not manufacturing at scale, but it's a heck of a start. And then we've got really cool partners with like IACME, or some of the other, manufacturing centers have some fantastic programs. And it's really all about like showing them this pathway that it's again, that interface between digital and physical. You can do all the math, you can do all the digital, natives, but then if you really want to impact meaningful change, it's where the rubber meets the road, and it's really how you get that out into the wild. Right. And so
go ahead.
Oh, so specifically what we do for that is, the NCAT website itself, and we can, if you can put it in a end screen or something like that, that'd be great. We've got a ton of great resources for high school students and educators. We have a drone lending library with 40 drones in it. It's got some VR headsets in it as well, some other stuff. But schools, any school in the country, can check drones out at no cost. We will ship you 20 DJI Telos or co-drones, and you can use them in your classroom. And when you're done with it, we will send you a prepaid return label. You couldn't pay us if you tried. And in terms of getting kids interested in Scratch programming or how things fly, it's a really interesting resource that a lot of educators can use without having to spend limited resources on what they already have. Above and beyond that, we have course curriculum, and not some of it's straight on semester long curriculum, some of it's unit activities of, so you got these drones, now what are you going to do with them? Luckily, because Steph and I breathe drones, we breathe autonomous systems, but for the teacher that's trying to keep their head above water, they want a package. They don't want to spend their limited nights and weekends researching the world of drones for something that their students may or may not be interested in. And so that's really where we kind of try to help. And then the final thing we do for high school teachers is we have professional development grants. And that is a really, really interesting way for high school teachers and two-year school educators as well, to really get up to speed on the state of the art of what autonomous technologies is. So a good example of what we do with that is AUVSI, is Association of Uncrewed Vehicle Systems International. It is the largest trade group for autonomous systems in the nation. And every year they have an incredible conference called Exponential. This last year, I think we sent 5 or 6 folks out to it completely on our dime. And they were able to take that knowledge back to the classroom and integrate that into their class programming. And so all that stuff is available through the NCAT website. And literally, as Steph and I have said, the role that we serve in existing here is specifically to help that out. And the other part of it too, over to Steph, is really how we integrate some of that into traditionally underserved communities.
And can you tell us a little bit more about the professional development grants? Like, how is the application process for that? And,
there's a
period.
It ends up, so it's rolling, which is the best part about it. Yep. You don't have to have, if something pops up, you don't have to miss out because you missed it. Generally, we do like at least 2 months heads up, because getting you into the system, getting everything set, getting the review process done, isn't something that happens overnight. But the types of events that are eligible for it, they need to be related to autonomous technologies. And so, and again, if I'd have done my homework properly, I probably could have found some sort of manufacturing. There's really interesting aviation maintenance conferences, aviation education conferences, and it's stuff that can be used in the realm of autonomous technologies is really the type of stuff that we are excited to fund. The AUVSA one just happens to be very, very well aligned. But definitely go through the application questionnaire. We might ask some follow-up questions. And if it fits with what our funding source will allow us to do, we really like supporting students, and we really like supporting educators as they want to bring that into kind of a bigger context.
So I think one of the things that I've noticed too with like high school programs that focus on tech stuff or any kind of manufacturing or engineering stuff, one of the issues is that kid, like you said, it's like you don't know what you don't know. So one of the high school that I graduated from, they have a really good CNC machining program, but they were having problems filling that particular course up because not everybody, when they look at CNC, knows what it means. So how do you update these course titles so that people know what it is and that it would be something they could relate to and find interesting and maybe possibly sign up for? So what are you're saying autonomous technologies. So would that be the course title, or is it like computer programming or programming or something? Like, what would the course be? Just so that I have a better understanding of like what these kids are signing up for.
Introduction to drones.
Introduction to drones.
That's perfect.
Yeah.
Yep. So the kind of baseline course that we kind of recommend everybody use is Introduction to Drones. And Steph and I have put a lot of work into this over the last few months. But really the idea focuses on use case of autonomous systems And so it's a good overview of how autonomous systems are being used across domains currently, the underlying technology, both on the airframe side of the house as well as sensor package side of the house.
Okay.
And then really kind of talking about how those work in concert to create meaningful value in industries that aren't aviation, right? Because that's where autonomous technology gets really exciting, because the folks that benefit from it the most aren't from that traditional core industry, right? Autonomous drone. We fly drones in Minnesota here to find deer. We use them to, map out watershed ditches. We used them in Nevada to try to find gold. That was an interesting project, but you use it for a bunch of really interesting stuff. And then we leave the students and the teacher with kind of a final project of knowing what you know now. How could you use a drone in a unique way to solve or meet a challenge that you have in your own experience, right? Because the applying to your own situation, I think, is a very, very important part in understanding the far-reaching value of autonomous technologies.
So then what sort of education opportunities are you actually providing for the teachers themselves? Because that's another issue that we're seeing a lot in manufacturing, where because technologies are advancing so quickly, some of these teachers are kind of left in the dark and not really given an opportunity, or if they want to like upskill their own, knowledge and wisdom, sometimes they might have to pay for it. Yeah, there's opportunities where they can get reimbursed for it. But like one of the things that I'm learning through working with the high school that I graduated from, there is politics involved with district funding. And if they don't have the funding, it's really hard to add like new curriculum. It's really hard to get resources for teachers. Sometimes teachers are taking money out of their own pockets to do this. So like, does NCAT offer some sort of training for the teachers?
So if you think it's challenging talking about manufacturing in that context, add into that phrase, and we're flying what the Federal Aviation Administration considers aircraft, and then see how the folks respond at the administrative level. So it's definitely empathize with what you're talking about, right? And really that's where that professional development grant really comes into their own, because it really ends up being a kind of a cool choose your own adventure type thing. So whatever is, interested in the technology, interested in the cars, it could be robo cars, a $200 autonomous technology using AI to drive a remote control car that you build yourself around a track, right? It could be, going to a talk by Rispa, which is down in Mississippi, that has, the size of a Cessna 172 autonomous aircraft. It's really what's the most interesting to the teacher. And then the strategy that Steph and I took for the classroom modules was really kind of be that background. If you want to go super deep, go to a PD, and we will help support that completely outside of the school, like you said, political system. But then if you want to just do something in the classroom, this is something you can download. This is something you can open. And even if you've never flown a drone before, we give you step-by-step instructions to give you the skill set that you can learn on the fly without having to spend all the time of building, of flying, of crashing and rebuilding again.
Right. And what he's saying is actually true, because I know nothing about drones. And as you can see, Aaron knows everything about drones. And so when we designed the lesson plans, we designed them with me in mind, because I taught for 20 years, but I taught literature. There's no way I was going to be able to just sit down and talk about drones, let alone teach someone to fly them and all that kind of stuff. So it's very much step by step. It's very user friendly.
So then my question is, because I just feel like if this was open to anyone, we would run into some problems with everybody flying drones all over the place and then it crashing into each other. So what are some of like the guidelines or whatever for you to actually sign up? Like, do you have to be part of a school that's partnered with NCAT to be able to access some of these materials? Because you're saying you can download them for free, and you're telling me that. So now I'm like, I'm going to go online and download this and try to fly a drone. Like, and I don't know if you want that to happen, because like I can get into trouble with that?
We 100% do. And truthfully, so in terms of getting involved, and this is both for high school educators as well as the 2-year students, 2-year educators as well, is, the content that we have available online. We have some high school content. We actually have over 100 classes through the curriculum library for 2-year educators. And all you need to do to download any of that is create a profile on the NCAT website. And then from there, you can use it however you like. The 2 things that we do ask is if you source it from, NCTC or, Sinclair Community College or any of the other really cool, exciting, schools that contributed to the content, if you'd please give them credit. And then the other thing that we definitely ask is if you improve on it, definitely let us know that as well. The entire idea behind this is to create a working body of knowledge that is accessible for high school and 2-year educators so that they don't have to start from ground zero. Because as much as Steph has learned about teaching drones, I've learned about teaching. I didn't know what a lesson plan was. And apparently there were standards that you had to tie things to. I was in so far over my head that it was, and really the idea here is to create that resource so that you don't have to start from ground zero, that you can leverage, the collective knowledge of us and our partners. And truthfully, if you're a 2-year school, a high school, or a nonprofit, we would love for you to be involved. And then the same thing is true with the lending library. So the lending library is open to high schools, 2-year schools, and nonprofits. The only thing that we do ask with that is if you could keep it for less than a month and a half, just because we have a limited amount of drones and other schools need them too. So
what if you're a technical writer / podcast host who likes to get younger kids excited about things within engineering and manufacturing that could use this as a recruiting tool?
I'm pretty sure if they also did volunteering with the high school that they worked at that you mentioned and had a podcast, that's definitely something within the realm of stuff that we can support, right?
So we're going to have to talk about this. And then I can have conversations with Stephanie and be like, how do I get a hold of your lesson plan so that we can
sounds good.
Get this to that. So Stephanie, do you know how to fly a drone now?
I can get it off the ground.
We gave her a flight lesson at the historic Stanford Field in southern Minnesota. It was a World War II airplane training facility. And Steph and I sat out on the hangar front deck. And I taught her how to fly.
So cool. Do you have video of it? You guys
Not of that.
You guys got to start capturing these moments and then start posting them to your website. So when I worked with the trade publication, when I first started in the industry, we got a hold of a drone, and I never flew it because I was too scared to do it, and I was not going to be the person that damaged it because I was like, I was like, you're not going to blame the girl for this if it breaks. I'm not going to set myself up for failure. So we have a video of our, his name is Chris Fox. He's no longer with the company. We've all moved on to other things, but we have a video of him in the remote control running across the camera view, chasing after the drone, and then we did a shot of it stuck in the tree because he got it stuck in the tree. So it was a pretty funny drone blooper video that we did. But I do want to be mindful of both of your time, and I do want to get to what your plans are for next year. Like what are some of the things that you're going to be focusing on, and what help do you need from either myself or communities or audience? What sort of things are you working on?
We are really working on trying to make sure that 2-year colleges know that this is something that we're willing to help them, put into their curriculum. Their 2-year schools are able to provide less expensive yet quality education, as we've talked about. and in manufacturing and in aviation, but they're often overlooked by four-year schools. And we find that that's kind of historically because high school counselors would really push four-year degrees, but we're seeing movement. I've seen movement when I was in the classroom, especially in younger counselors coming in towards seeing students' individual interests and their success in technical classes, and then promoting career pathways to those two-year technical colleges. But we want to see more of that. We want to see, and that really comes down to our other challenge, which is publicity. We're a small group. There's only 5 of us basically, and we're trying to get the word out about NCAT and how we can assist the public. So it's been a challenge, but we do know that only like in Minnesota, for example, less than 20% of community colleges pay, or community college students pay the full tuition. And then there's additional support for families that have incomes less than $80,000 a year. So the money is there, the need is there. We want to make sure that people are aware of it. And so just kind of getting that out there.
Okay.
And in addition to kind of the educational pathway conversation that Steph summed up, these two-year schools, if the really exciting stuff that's going to happen in the next 10 years is all going to come from two-year schools in my mind. As part of that, though, in the conversations we have with two-year schools, they are absolutely slammed with the amount of stuff they have to do, with the short resources that they have to do it in, and then the timeline that they're supposed to get it completed within, right? And so really one of our big goals for this next year is to collaborate more, is to make that connection with the larger two-year system. Whether it's NCAT, some of the great resources we've talked about today, but also connecting them with the larger NSF ATE program, the National Coalition of Advanced Technology Centers, based out of Ohio. That's actually where I met Danny, that connected us at their conference back in September. They are, connecting them no matter what your focus is. If you're a two-year school, there's something within the NSF ATE community that's going to be a good connection for you to make. And really, we understand that not everybody goes totally nuts on drones like we do, but there's this really phenomenal community of two-year educator and resources and support out there to support these schools. And then the final one is really that conversation with industry. One of the things that we've noticed, especially in the autonomous world, is a lot of schools or a lot of these startup companies, and partially because they're startups and still need to guard trade secrets, and completely understand and empathize with that. The challenge is that some of them are attempting to recreate two-year degrees in their traditional onboarding programs. And as a National Center for Autonomous Technology, in any NSF ATE center, we don't need to know how the bacon's made. We don't need to know any of that stuff. Our job is to create quality composite manufacturers, is to create quality additive manufacturers, quality aviation maintainers, cross-queue them, and so they can get some learning from the electric automotive folks, and really create that so that the hires walking in through their front door, the new hires walking in through industry's front door, know the basics and then can get trained up on the specifics of the company. And having value-added conversations with the company, again, not asking for anything proprietary, but understanding where they need their graduates to be meaningful contributors, is something that's really important for us, because especially in the two-year system, not tying something to a job outcome is a recipe for failure.
Oh, 100%. I agree with that. So then are you still going to try to do some four-year colleges or no?
Within the ATE program, we focus exclusively on two-year schools. Some of the partner groups that we do a lot of good work with, the FA on UAS Collegiate Training Initiative, they focus on 2- and 4-year schools. Some of our other partners, IACME and such, they are a little bit less particular about 2-year schools. But the NSF ATE program is really focused on that equity concept of making sure that the 2-year graduates have the opportunities that they rightfully deserve.
Well, and I just remember when I graduated college, I still didn't know what the hell I was going to do. Like, I had this degree, and I'm like, what am I going to, like, how do I apply this to the real world? And, I mean, you're an English major, Stephanie. Like, there's not a lot of, unless you wanted to be a college professor or a teacher, that was like the two options presented to me at high school. And I was like, well, that doesn't sound fun to me. And then I learned about technical writing like my third year of college. So it's just like, well, why didn't they bring this up when I was in high school? Like, this is more up my alley kind of thing. So like defining things and making sure that it's cool. Did I introduce you to SME? Did I do that? Or do I still need to do that?
If SME.
So that's the Society of
Manufacturing Engineers.
Yep, and I told you that they at Fab Tech announced working with technical schools specifically. And just a disclaimer to anyone that's listening in, and you went to a four-year college, like, we're not saying get rid of four-year university at any means. We're just saying that there's other options for people to go through, especially for people who just don't want to spend a whole lot of time in school. Like myself, like, I probably would have done a lot better at a community college than the university setting, but I made it, got through it. I thought I introduced you to SME, but I'll make sure to do that after this, because again, they announced a new program that they're doing with community colleges specifically, and they're looking for like curriculum and how to connect students to like real world type opportunities. And most of the stuff that they're focusing on is like CNC machining, automation, and robotics. But this could probably pique their interest. So if I didn't introduce you before, I apologize. I'll make sure to do that after this.
That would be great. And if it doesn't fit within the work that NCAT does, it guaranteed fits somewhere within the framework of what NSF ATE does.
Okay.
I know NCACT, they do a lot of work with SME and a few of the other manufacturing organizations. I just don't know them off the top of my head because I spend my time thinking about drones.
Well, and there's too many to count, and they all have similar acronyms or different acronyms. And I swear I want to make just a book, like a book that has all of the acronyms in engineering and manufacturing. It's like a acronym dictionary. I'm sure there's one around, but yeah. So, well, I want to give you guys a chance to ask our audience something. So if you had a big ask for our audience, what would that be?
Connect with us and let us help.
Yep.
Simply put, I think
help us get the word out.
The getting the word out, and especially for folks that are on the fence about the interaction between digital and physical, which is very much what manufacturing is. Drones are a really exciting, non-confrontational, video game adjacent way to get that through the front gate, right? And so, I think that would be an exciting place to start the conversation, and then really figuring out how we or other folks within the NSF ATE community can support the work that I think all of us are so passionate about.
Okay. Are there any events that people can catch you at? Like, there's a ton of trade shows that happen, like IMTS and Pack Expo. Is there anything specific to what you're doing?
We have two exciting ones coming up within the next year or so. One of them is going to be for all of you VEX Robotics folks. The World Championship is, I believe, in Dallas again this year. And we are talking to St. Cloud Community Technical College that has a booth about co-sharing a booth with them this year. So that would be really exciting. And then the really exciting one is in August of 2024. For the last 3 years, we've been hosting an event called Experience STEAM at the Mall of America. And this year is going to be another one. It's going to be a large VEX Robotics event, 100 teams competing. We're going to have a STEAM carnival where nonprofit partners around the state can come and show hands-on, no-cost tactile activities to teach STEM concepts. And then we're talking with some other groups about professional development and summer camps.
Yeah.
And this is at the Mall of America?
Yes. And
at the Mall of America.
It takes over the whole mall. We have places, we have events everywhere. So
they gave us right around 33,000 square feet the last few years to do it.
Yep.
So this is August?
August. We're still working on final dates, but first week or 2 weeks of August, it's going to be a Friday through a Sunday, and it is a blast. 100,000 people go through the Mall of America on an average day, and so it's a really exciting way to get in front of a lot of non-traditional audiences and have that specific education and career pathway conversation.
I have family that lives in Minnesota near there, so I will bring the whole family.
Come on up.
And
awesome.
we'll participate, and then I will bring a camera too and do a live or a recording interview with you guys if you don't mind. That'd be awesome.
Really
Yep.
Okay, so then this is my final question, I promise. How can anybody get a hold of you? How can they connect with you? Where should they go?
The website is ncatech.org. And then the individual email addresses are probably a little too long to say here.
That's okay. I can drop them in the comment sections too. Otherwise, I'll just have them connect with you on LinkedIn if you guys are open to that. I know I know some people don't like connecting with everybody on LinkedIn, but it's the great way to get that out there. So make sure to follow their LinkedIn page too if you're tuning in, because they have one on there. And then I'm definitely going to keep in touch with you guys because I really want to help you get some more awareness onto your brand, and hopefully maybe I can get access to the curriculum and learn how to fly a drone and make some cool content around that.
Yep, just email me.
Okay, I'll definitely do that. Well, thanks you two so much for taking the time. I really appreciate it. And anyone that's listening in, thank you for tuning in on a Wednesday. I know this is out of normal for me, but I just thought this was a really cool organization, and they're doing some really cool things to get kids excited about. I keep calling them kids, young adults, excited about the tech field in engineering and manufacturing and autonomous technologies. So everything that they mentioned, I'll have a link to, especially to that event at the Mall of America, because I think that's really cool. But thanks, you guys. Have a great week. Don't forget to tune in on Friday. We got another great episode of Mavens of Manufacturing coming up, and I hope you guys have a great day. Talk to you soon.
Thank you.
Calling all engineers, technicians, and automation pros. Are you ready to take your career to the next level? Don't miss ISA's Black Friday week sale November 20th through November 27th. Save 30% on industry-leading trading, books, events, and standards. Get additional savings at the ISA merchandise store. The best automation deals are just around the corner. Visit isa.org/Black Friday Week 23 to learn more. That's isa.org/Black Friday Week 23.